So I have a video to play about this, but I thought this was interesting. Teaching this class is opening my eyes to a lot of different things. But there are actually just four or five things in the Earth's atmosphere that the EPA is worried about. So they're called the harmful few. So what do you think that first one is? Carbon monoxide. Yep, very good. Carbon monoxide is the first one. What about the next one? Ozone. Very good. I think it's interesting. Ozone has 3 oxygens, so the formula for ozone is O3. And I just think it's interesting how there's bad ozone in the troposphere, but good ozone in the layer above the troposphere, which is the stratosphere. So my idea is you just pipe it up there. What about this one? Sulfur dioxide?
This is like a problem I got stuck on, so I don't.
Oh.
I had to do it a couple times too.
Yeah. I wonder it's just a glitch with that. Hopefully. Glitchy. How about this one? Nitrogen dioxide. Yep. Nitrogen dioxide. Yep. And then the last one, I like how it says it's the least understood. What's the last one?
Particulates.
Particulates. Yep. Very good. Particulates. You got it. So that's what the EPA is most worried about in Earth's atmosphere. So let's take he called it sulfuric acid. It's H2SO4, not H2SO2. So I'm not sure where he got that from, but that's right. So PM stands for particulate matter, and I thought he did a good job. We kind of put it relative to the shaft, your hair shaft. I think was it 10 PM10s can go across. So what we're worried about is PM10s, which is what we call 10 microns, and PM 2.5s, which is even a fourth of that, 2.5 microns. So I guess I had this down here. It's kind of silly. But PM10 is 10 microns, and a little subscript, PM 2.5 is 2.5 microns. And like he said, they hit our lungs, our cardiovascular situation, so they can become embedded and give rise to cancer or irritation, or it's just not good. So we've already talked about these terms, but we're going to see them again. Percents are parts per 100. Okay. Another common thing then is parts per million, or ppm. And so what do you think? If you had, that would be 0.4 ozone molecules for how many molecules of air atoms? It's parts per million. What goes down here? 1 million. 1 million is 1 times 10 to the 6th. So if something is 0.4 parts per million, that's what we're talking about. In this case, 0.4 parts per million O3, or ozone. Here's another one for you. Instead of parts per million, it's parts per billion. It says sulfur dioxide in the air should not exceed 30 parts per billion. You're going to see it here on the table in a minute. So if it's 30 sulfur dioxide molecules, it's 1 times 10 to the what? Molecules of air. Yep, 1 times 10 to the 9, or 1 billion parts per billion. Sometimes things like this I have to concentrate and get it right, but yes, very good. So can you kind of see, we talked the other day, how do you go from parts per million to parts per billion? Times 1,000, yep. How about parts per billion to parts per million? Divide by 1,000, yep. Yep. So again, parts per thousand we don't use as much. So we're converting 21% to all these different concentrations. Parts per 100 we don't do much. Sorry, parts per 100, yes, a lot, that percent. Parts per thousand, not so much. So it's 21, it's 210 parts per thousand. How many parts per 10,000? 2,100. How many parts per 100,000? 21,000, yep. How many parts per million?
210.
Yep, 210,000, very good. And now we're skipping not just a factor of 10, but a factor of 1,000. So how many parts per billion? Right. Sometimes I'm like, now how would you say that number? Yeah, so that's 210 million. 210 million parts per billion. And I had down here, note the difference between percent and parts per million is a factor of how many? So percent to parts per million.
10,000.
10,000, yep. So that's a common leap. Very good. Okay. So when you assess the risk to do anything, like fly, go to college, okay? When we assess a risk with regard to air pollution, we are looking at it in an organized fashion, looking at the data. So the word is organized there. We're not spazzy about the whole idea of assessing the risk of these pollutants. Science doesn't go willy-nilly. In a minute, you're going to see these air quality standards, and they are generated by the United States. We're going to switch gears, and I'm also going to show you the WHO, which stands for WHO.
Something health organization.
Yep, health organization, and the W is the World. Yep, World Health Organization. So they're slightly different. The word here is EPA. So like the dude said when we watched, that the Clean Air Act in 1970 was a big hairy deal, and that's gotten us down the road to. Here in a minute, I thought of you guys when I was looking at the slides for today, because we're going to actually see that our air pollution levels are declining. They have declined. So, and a lot of it's because of keeping things off this way.
That's crazy that London, that I never heard of that before.
What's that?
Or the 10,000 people died.
Yeah, the great.
Okay.
I've never heard of it either.
And it was a weather pattern thing in London. So many people died. I've seen videos about it. But did you also know, with regard to particulates, like the Great Dust Bowl, again, that was kind of a farming weather issue, but all those particulates, people died. A lot of people died from that too. So within assessing how much risk we might be, might come with exposing our bodies, we need to talk about exposure now. Exposure includes both time and rate. So those are the two words. Exposure is how long you're exposed. And the rate here, I thought this was interesting, is like the rate of breathing. Because, like if you're exercising or something, you're going to be exchanging a lot more volume than if you're just normally sitting sedentary. So that just means don't exercise. But anyway. And then, of course, the toxicity is related to our health. Okay? So everything with regard to exposure and toxicity needs to go into these levels that were set by the Clean Air Act in 1970.
So the air's cleaner still, even with like all the more vehicles?
I believe so.
Just because they're quick burn cleaner.
Yeah, she's asking if the air, I think so. Because the graph that's in your textbook kind of breaks it out into the different pollutants. So, but that's true. I mean, you would think there's more cars, but maybe they're more, are they cleaner? I don't know, those
I
SUVs.
feel like they have higher emission standards.
The standards that they put on the car makers.
But there's so many more cars than there were.
Yeah, yeah.
I agree.
So we'll see the trends in a minute, but this is what the EPA put out, and I don't know, it's probably been tweaked between 1970 and now, but this is what they are now. So at the top is the standards. These are going to be in parts per million. And then the last column, and let's see, the metric prefixes, the ones that I worry about usually are kilo, and that's a K, and that's a 1,000 times. Milli then is a little small m, and that's 1,000th of, like a milliliter is 1,000th of a liter. And then this one is an important one. It's called micro, and it has the Greek letter mu, which is a U with like a little hoop on the end, so that's micro. And that means 1 million. So here we have micrograms per meters raised to the third power, micrograms. So this is a meter stick. It's a dare stick. This is a meter stick. So if I were to, and each of these blocks is about, so it takes 3 blocks to make a meter, so this works. So if I was going to make a box this high, and then the other corner is right here, so it goes 3 by 3 by 3. Okay, so that box right there, okay, that's 1 cubic meter. So these limits are going to be micrograms, which is a very little bit of a mass, micrograms of these pollutants per 1 cubic meter. So anyway, those are approximate. So sometimes we see 2 values, and this is for carbon monoxide, CO, and actually this is the main pollutant of all of our automobiles. So notice that if you are going to be exposed for 1 hour, you can go to 35 parts per million is your upper limit. If you're going to be exposed for 8 hours, which is longer, you can only go 8 parts per million. I know working at the ammunition plant, one of the things they would do sometimes is wear these badges, which is, and I think radiologists wear them too, to basically track their exposure to different things. So in terms of micrograms per cubic meter, it looks like this. Do you guys have to go in all these numbers? So the first one is 40,000, and the next one is 10,000 micrograms. So let's see, that's a microgram. So kind of to go back and forth between micro and milli, does this make sense? A factor of 1,000? So I could go ahead and actually go the other way. It would be 40 milligrams and 10 milligrams. All right, so what do you got next? Nitrogen dioxide. You're looking at 0.1 if it's a 1 hour average, or a yearly basis, 0.053 parts per million. It's nitrogen dioxide, and the source for this are power plants and stuff. In terms of micrograms per cubic meter, you're looking at only 200 and 100 for those exposure times. So ozone, what's the formula for ozone? O3. So on an 8 hour average, you should only be safely exposed to 0.070 parts per million. In terms of micrograms per cubic meter, 140. So particulates. We've got the larger particulates and the smaller particulates. And for the smaller particulates, we've got the daily average and the yearly average. So those numbers don't apply there. They're all not applicable with regard to parts per million. But with regard to micrograms per meter, they look like this. For the PM10, you're looking at 150 micrograms per cubic meter on a 24-hour basis. If we compare these two, the 150 and the 35, which one seems more deadly? The PM10 or the PM2.5? The PM2.5. And with regard to on an annual average, I'm not sure how that works, on an annual average, you should only be exposed with regard to the small particles, only 15 micrograms per cubic meter. Sulfur dioxide, what's the formula for sulfur dioxide? SO2. You're looking at 0.075 parts per million. And then with regard to micrograms per cubic meter, 210. Now it's your turn. Use that data, and if you can't read the table, which I hope you can also find it in your book on page 52. So take a look at it, and I'm going to ask you guys what you think. Which pollutant listed is likely to be the most toxic? Let's just do that. Which one's likely to be the most toxic? And why? Which one? Nitrogen dioxide. Nitrogen dioxide. Very good. And why?
Because you can have the least amount of whatever.
But don't we play devil's advocate though? Which one do you think? 2.5 particulate? And she went with, I could see that too. She went with just this 15. That's 15 compared to the 100.
We don't have 15 of that.
I can see a case.
It says exclude.
Oh, what's that?
It says exclude particulate matter.
Oh, it says exclude particulate matter. Okay. Good. Okay. So look at those again. Fine particulates are 2.5, more toxic. Do the values in this table support this claim? I think we kind of, you already answered that question. Because I asked you these two guys. And you said that since 35 is less than 150, that supports that claim. All right, good job. Here's another one. So sulfur dioxide is released in the air when copper ore is smelted to make copper metal. Let's assume that a woman living downwind inhaled 44 micrograms of SO2 in an hour. Okay, now, goes on to say that in an hour's time, she inhaled 0.625 cubic meters. Has she exceeded that limit there? Support your answer. I think I'd have to use a calculator for this. So that last column for sulfur dioxide, it gives the limit for micrograms per cubic meters. And in this problem, you have micrograms of 44, cubic meters are 0.625. How many people think she is in trouble? How many people think she's safe? Why do you think she's safe?
Well, I didn't do any calculations, but looking at it, she didn't reach the amount of time that she can be speaking.
She only had 44.
But she was there
For an hour.
an hour.
The exceeded limit is 210 for an hour.
I think you divide those out and then you compare it to the chart. I got 70.4.
She still exceeded. But it's 210.
210. And Natalie said she was okay. Yeah, I think she's okay. Does that make sense, though? She doesn't have to move. Let's see, a follow-up question. If she were exposed at this rate for 3 hours, would she exceed the 3-hour average? Wouldn't it be the same?
Because per hour she was only getting 70.
Yeah, and so she'd still, if she's getting 70 in 1 hour, and if it's the same rate, her average for 3 hours is going to be 70.
I think if she's even having to think about this stuff, she should move.
I like that. And you know, the problem with limits is everybody's responds a little bit differently. So, yep, I think so too. All right. So, those were EPA, and these are the World Health Organization. Yep, here's the World Health Organization table. So it's a little bit different. You see these countries here by income. When I was looking at this, so this is by income. I actually got this, and if I take this link, it will take us out to, who was it? One of these cities, and they're excited that they're getting better. But I wanted to point this out to you. Check out the United States. In 2011, they checked 174 of our cities. They checked 375 of our cities, and 174 of those failed. So with regard to meeting, and this is just the 2.5 particulate matter. So we had a 46% failure rate.
And everyone else was 100.
What's that? I know, yeah, France. And this is interesting. You can already see France, they checked 4 cities in 2011, and they checked 80 cities in 2014. Some of them was
the cities with more industry?
I would think so. They would probably target the larger cities. Yeah. Yep. So 3 years later, instead of 174 cities, instead of 375 cities, in the United States, they checked 379. And now only 105 of them failed. See? That's about 28% failure. And then 2 years later, they checked 372 U.S. cities. Only 38 failed with regard to particulate matter. And Taylor's point is, well, take us like, which cities are they checking? And my guess is that the majority of the 375 and 379 and 372, they probably have similar cities that they're coming back to. And I think that, I'm going to go ahead and take us out to, which country was it?
Spain, maybe, or France?
That saw their decrease. They were real excited.
Spain went from 67 to 67 to 36. And
That's
France
true.
Went from 100 to 99 to 72.
Let's see.
Or
I
Brazil
think France would be better than
from 100 to 98 to 84.
Yeah, France, that's 2. France doesn't look very good in this whole thing. This is just where I got it, the article I got it from. And you know the internet doesn't lie. No, actually, I think that I'm okay with this data, this article. Delhi, no longer the world's most populated city. Polluted, yeah. I'm sorry, polluted. That starts with letter P. So Delhi is in, thank you. So there they are. They're excited. They're going down. That's kind of their, and I'll post this out there on Twitter. So India, wow. I mean, India got hit hard they didn't make the first examination. But yeah, India, in 2014, they looked at 124 cities and 123 failed. That's not good. But
I'm still at 99.
This is like, oh, I'm sorry, but I didn't quite process it until, yeah. So apparently Delhi is one of these guys that
We got one less city that failed. So
They're the one that passed.
Yeah. Wow. I know.
China is doing pretty bad. For how many did it?
212.
China's like,
All of our stuff comes from China.
I
it's true.
know.
I think they're all random masks. That's probably why.
Masks are, yeah. Anyway.
I'd see them. They wear them in Wyoming. They come dog sledding and they'd be wearing them. That's pretty clean here.
Really?
Yeah.
That's interesting.
So,
Was it cold, maybe?
but like, well, you
It's
can wear
particular.
it like a scarf. Those things are very cool.
Maybe just have it.
Yeah.
Oh, that's kind of sad. All right. So, yeah, take off your muddy shoes at the door. I've never said this before. I'm not going to clean the carpet after you.
You never said that?
I don't think so. Have you ever heard it before?
Oh, I say all the time.
It just makes sense, that right? So the whole point is don't emit it, right? So what are ways that you can think of to help prevent air pollution? Just kind of throw them out there.
Make sure your car meets emission standards.
Car meets emission standards. Don't burn your trash. Put it in the landfill.
Oh yeah, was that worse?
I don't know. What are other ways to try to make the air cleaner? Recycle? Carpool?
Why doesn't the school recycle?
What's that, walk instead of driving? Yeah.
You gonna walk from home? 3 miles away.
I think they've tried recycling, but I saw this video recently. Maybe it's why I was looking for videos for you guys. And I saw it on Facebook. And in which country? It's one of the long ones, like Sweden or one of those guys. And they have, when you're done with the can, you go put the can in the thing and you get your money back. I don't know.
Yeah, that's like.
Oh, they have that at Walmart. Well, you sell your cans back to Walmart.
Yeah, but it's such a pain because you have to have somebody
You have to,
take your dirty
collect them
cans.
and then
Yeah, but this was you just put it in there and then, I don't know.
it was like right there.
Yeah. So that's true. Walmart's not too bad. Let's see what we got here. So this is, the different colors are different pollutants. So this is what I was trying to tell you about. Oh, and the ... is the most recent standard. So if we're below the ... that's a good thing. And so we were talking about cars and the carbon monoxide emissions. And it doesn't, so this is that dark blue line. So I don't know, it looks like we've kind of evened out, doesn't it?
Yeah.
Yeah. But we're definitely below what we said would be harmful. What's that orange one? Oh, yeah. So what element is that?
Was there still lead and fuel then? No. I don't know.
I wouldn't think so, but
3 months.
maybe lead in paints and stuff. But yeah, it's gone down. So I thought this is kind of cheery. Do you see anything going up?
He's like it changes.
Yeah, lead is really noisy, isn't it? Yeah, because it's gone up and then down and then up and then down.
Everything else just goes down.
Everything else is kind of at a gentle slope down. Yeah. This guy, I mean, why have these colors so close together? So that's the 25.
After that peak right there, just going back down.
Yeah, that's true. That looks like a between 13 and 14 is going down. So yeah, not bad. So reasons for air quality to improve include regulations. So in 1970 was the first one, the Clean Air Act, and then the whole thing of pollution was readdressed in 1990, where they emphasized prevention instead of just don't emit it, don't create it in the first place. They have incentives and things like that. So another thing, I heard you guys say walking or carpooling. Many cities now have public transportation, which helps as long as it works. New technologies to reduce emissions, and green chemistry. So I have a little video to show you green chemistry.